Hi. Welcome to Math Den, a series of math topics tutorials. This covers algebra, geometry, trigonometry, probability, statistics, calculus, and business mathematics. Today's topic is the properties of rational functions. The fourth property, the horizontal asymptote of rational functions. The properties of rational functions are important and prerequisites to graphing of rational functions. Meaning, these are needed to be able to construct better the graph of a rational function. We are done with the first property, the domain of rational functions. The second property, intercepts and zeros of rational functions. And the third property, the vertical asymptotes of rational functions. Watch the previous videos about that. The next property is the horizontal asymptote of rational functions. Here is the definition of horizontal asymptote. The horizontal asymptote is a horizontal line denoted by y equals b. b is any value from the y-axis. It is where the graph approaches without bound as x increases or decreases. For rational functions, a given function may or may not have a horizontal asymptote on its graph. Meaning, a rational function may have only one horizontal asymptote on its graph. Or, it has no horizontal asymptote at all. Also, take note that the graph of rational function may or may not intersects the horizontal asymptote. For example, this rational function has horizontal asymptote at y equals 4. But the graph intersects the horizontal asymptote. It is possible. This next rational function has horizontal asymptote at y equals 0. But the graph intersects the horizontal asymptote. It is possible. While this third rational function has no horizontal asymptote at all. In order to find the horizontal asymptote of rational functions, follow these rules. Let n to be the degree of the numerator, and m to be the degree of the denominator. Rule number 1. If n is less than m, meaning the degree of numerator is less than the degree of denominator, the horizontal asymptote is at y equals 0. Rule number 2. If n is equal to m, meaning the degree of numerator is equal to the degree of denominator, the horizontal asymptote is at y is equal to a over b. A is the leading coefficient of the numerator, while b is the leading coefficient of the denominator. Lastly, rule number 3. If n is greater than m, meaning the degree of numerator is greater than the degree of denominator, there is no horizontal asymptote at all. Example number 1. Determine the horizontal asymptote of this rational function. F of x is equal to 4x squared plus 4x plus 1 all over x squared plus 3x plus 2. Since the degree of numerator is equal to the degree of denominator, the horizontal asymptote is y is equal to the leading coefficient of the numerator over the leading coefficient of the denominator. That is, y is equal to 4 over 1. Therefore, the horizontal asymptote is y equals 4. Draw a horizontal dashed line at y equals 4 to denote that it is the horizontal asymptote of the given rational function. Example number 2. Determine the horizontal asymptote of this rational function. F of x is equal to 3x plus 4 all over 2x squared plus 3x plus 1. Since the degree of numerator is less than the degree of denominator, the horizontal asymptote is y equals 0. Draw a horizontal dashed line at y equals 0 to denote that it is the horizontal asymptote of the given rational function. Example number 3. Determine the horizontal asymptote of this rational function. F of x is equal to 4x cubed minus 1 all over 3x squared plus 2x minus 5. Since the degree of numerator is greater than the degree of denominator, there is no horizontal asymptote on the given rational function. No horizontal line to be drawn, because the rational function has no horizontal asymptote at all. Now, it is your turn. Determine the horizontal asymptote of the following rational functions. Pause the video and write your answers in the comments section. Thanks for watching. See you on the next video. Don't forget to subscribe and hit that notification bell for more video tutorials.